first series of the topic construction of formulas and equations. Construction of formulas and equations is a very vital aspect in chemistry. It is a prerequisite to the fundamental of general chemistry and directly a basic requirement to understand stoichiometry and more concepts. To successfully construct formulas and equations, there is need to first understand how to determine and know the valencies of elements and other reacting species. Therefore, the main objective of this lesson is to define valency, to understand how to determine the valencies of elements and radicals. So let's begin by defining the term valency. Valency is the number of electrons an element needs to achieve an octet configuration. In simpler terms, valency is the combining power of an element. Let's look at this illustration to understand the definition. So we have said valency is the number of electrons an element needs to achieve an octet configuration. Now, if you do remember that on the periodic table, we've got metals and non-metals. So just roughly, if you can visualize the general structure of the periodic table, we have a zigzag line that differentiates the non-metals and the metals on the other side here. You do realize that the metals, they have fewer electrons in their outermost shell. Therefore, it is easier for them to lose those electrons in order to remain with an octet configuration. On the other hand, the non-metals have got a lot of electrons compared to what they are lacking. Therefore, it is easier for them to gain electrons. That is why the valency can be restated as the capacity of an atom to give, accept, or share electrons to achieve an octet state. So what we are saying is there are some metals, like for example, which have got fewer electrons in the outermost shell, such as 1, 2, and 3, and these ones, they can easily lose the one that they have. When they lose that the fewer electrons in the outermost shell, they are going to lose the entire shell altogether. Therefore, the next shell that is going to remain is going to have 8 electrons, hence octet configuration. But we also have elements that have got a lot of electrons, like in the case of the non-metals. These ones, they are supposed to gain, because for example, chlorine here, it has 7 of them. So for it to be 8, it only needs 1 more. Therefore, it will be easier to gain that 1 than to lose the 7. Therefore, in this instance, it will gain electrons, and we say it has accepted. We also have unique cases in the case of carbon, where these ones, they do not need to lose or gain, but what they need is to share. Hence, we are saying this definition in the dialog box here is actually a complete box, where we are saying is the capacity of an atom to give, accept, or share electrons in order to achieve the octet configuration. So that is the definition of what valence is. Just to sort out the confusion, there is a difference between valency and valency electrons. These two things are closely related, but there is a bigger difference. Let's look at this diagram here to fully understand the difference between the two. Now, we are saying valency electrons is just simply the number of electrons in the outermost shell of any element, whereas valency is the number of electrons that an atom can lose, gain, or share during a chemical reaction. Now, for certain groups, like groups 1, group 2, and group 4, as you will see soon, these ones here, you discover that the valency electrons and the valency will be the same thing. However, for groups 5, 6, and 7, this is not the case. Valency and valence electrons are different. So please take note that valence electrons simply refers to the total number of electrons in the outermost shell, whereas valency is the electrons that an element can either accept, lose, or share in order to obtain an octet configuration, which is simply the total number of 8 electrons in the outermost shell. With this background, let's go ahead and look at how we can determine the valency for elements in groups 1, 2, 3, and 4. In these groups, we are saying the simple rule for determining the valency of elements in these groups is that group number is equivalent to valency. That is to say, if something belongs to group 1, it means they have a valence of 1. Those that are in group 2, all those elements, they have a valence of 2. All the elements in group 3, they have a valence of 3. All the elements in group 4 have a valence of 4. Let's look at a few examples here. Sodium is found in group 1, therefore it's going to have a valency of 1. Magnesium is found in group 2, therefore it's going to have a valence of 2. Aluminium is in group 3. Aluminium is in group 3, therefore it's going to have a valence of 3. Carbon is in group 4, therefore it is going to have a valence of 4. Let's look at how we can determine the valency for elements in groups 5, 6, 7, and 8. We are saying for these groups, valency is given by subtracting. So here's the formula. We're saying subtracting the group number of the given element from 8, and this is because 8 is the octet configuration. So what we are saying is valency is equals to 8 minus the group number of the element in question. For example, if we are looking for something that is in group 6, then valence here will be equal to 8 minus 6, which is equals to 2. If you are looking at the valence of something in group 7, then valency is equals to 8 minus 7, which is equals to 1. Let's look at this one. So we are saying valency is equals to 8 minus group number, which means if you are looking at group 5, then valence will be 8 minus 5, which will be a 3. If you are looking at group 6, then valency will be equal to 8 minus 6, which is a 2. If you are looking at group 7, then valence is equals to 8 minus 7, which is equals to 1. If you are looking at group 8, then valency is equals to 8 minus 8, which is equals to 0. So all we are saying is the elements that are in group 8 are stable because they don't have valency electrons. A few examples here. We have nitrogen, which is in group 5. So nitrogen is group 5. That's why we are saying it's 8 minus 5, giving us a 3. We look at oxygen, which is in group 6. So it's going to be 8 minus 6, which we'll find to have a valence of 2. Let's look at how we determine the valency for transition elements. So we are saying transition elements have no fixed valencies but variable, meaning the same element can have more than one valence. For example, iron can have a valence of 2 or 3. To identify the valency for transition element, check the number given in Roman numerals in the brackets. Let's look at the examples that we have here. We know that iron is a transition element. So the name of the compound here is iron 2 sulfate. We can see in the brackets here, we've got a Roman numeral 2. So this 2 simply represents the valency for this transition element here. Please do not confuse it. It will not belong to sulfate, but it will belong to the transition element. So the first thing you're supposed to do is to actually find out which one is the transition element. The same iron, here it is called iron 3 sulfate. Again, pay attention to the brackets that are here and what Roman numeral is inside. So you find that here the valence is going to be 3, here the valence is going to be 2. So these valences that are put in brackets as Roman numerals, they belong to the transition element. The last one says, what is the valence of copper in copper 2 carbonate? Again, when you check in between here, there is a Roman numeral of 2 in the brackets, and the only transition element here is copper. Therefore, the valence here also is going to be 2. Let's look at how we determine the valency for radicals. Now, a radical is a group of atoms which is present in several compounds but is incapable of independent existence, which means these guys, they exist as a group, and the way they exist is the way they should exist. So for the valence of radicals, you simply need to master them as stipulated in any approved textbook for chemistry. Now, most of them that you're going to find in either IGCSE or ECZ, and most of the syllabus that we have, the syllabi that we have, these are the ones that are common. So here we have ammonia, chlorate, chloride, hydroxide, nitrate, nitrite, and these are the formulas respectively. So ammonia has got a formula, so this is ammonium, has got a formula NH4, and it has a valence of 1. So all these that are in this box here, the first box here, so all these that are in the first box here, they have a valence of 1. So for radicals, you are supposed to memorize their name, their formula, and their valency. This is going to be helpful as you navigate through the course of chemistry. Chlorate has got ClO3, valence is 1. Check on the carbonates here. Carbonate has got CO3 and the valence here is 2. So all these that are in here, they have a valence of 2. Then for the phosphate, which is alone here, it has got a valence of 3. So this table, all we are saying is you are supposed to memorize it. Now the challenge we are giving, I'm giving to you guys is, can you come up with a mnemonic on how you can memorize all these radicals in their order? Once you master these radicals, you are warm and dry. Everything will become simplified for you. Let's look at the summary when it comes to determining valencies. So we said from groups 1, they have a valence of 1. Group 2, they have a valence of 2, which means beryllium has a valence of 2, magnesium 2, calcium 2, strontium 2, barium 2, and radon is 2. So all the elements that are in this group, they have a valence of 1. All the elements that are in group 2, they have a valence of 2. In group 3, they have a valence of 3. In group 4, they have a valence of 4, and this is as a result of sharing. Then as you skip, you go to group 5, 6, 7, and 8. If you want, you can see that the numbers, they start reducing, decreasing. So we started from valence is 1, valence is 2, valence is 3, valence is 4. Then again, we go like 3, 2, 1, 0. So you can memorize it like that, it's fine. That's why we say the periodic table is a very important ingredient in everything that we do. So then the last part we looked at was the transition element, with the transition elements in this block, or the elements in this block, which have valences that are variable. It can either be 1 or 2 depending on the compound in which it is combined. Then we talked about radicals, which we are only supposed to memorize. So please, this is going to be very important. Go through this video, share it with your friends, go over and over, and once you understand valencies, everything that will follow will be a piece of cake. Thank you so much. Enjoy watching other lessons.